session with electrostatic potential and capacitance. Today we'll discuss with capacitors and capacitance. Already we have finished electrostatic potential. So today we are going to discuss a very important equipment of electricity, and that is capacitors. So capacitors and capacitance. You know that what are capacitors? In general form, when we go to the market and we buy, we say them condenser or capacitor. Now, what exactly means a capacitor? Actually, a capacitor is a device. You say that it's an arrangement. It's an arrangement. You can say it's an arrangement of two conductors separated by an insulating medium. An insulating medium that is used to store electric charge and electric energy. Now, if you have seen capacitors are basically they store the charge. They store the charge, and mainly you have seen it in electric motors and electric fans. If you see on the top of the fan, there is a type of a cylindrical capacitor. Same is in the electric motor. So that is that is like this type of capacitor with two plates, and you know that the wires are connected. One is positive, one is negative, and it's a type of a that cylindrical capacitor. So this is the common one which we use in electric fans and electric motors. So this capacitor is a cylindrical type of capacitor. Now I will discuss that how the capacitance of a capacitor is calculated. What exactly means a capacitor? Now, if I have two conductors like this, there are two conductors, and one has positive charge and the other has negative charge on it. Okay, this has say plus Q charge and this has minus Q charge. These are the two conductors separated by some medium. It has a potential say V1 and V2. Now, do you know the potential difference between the two conductors? There is a potential difference, and that is V1 minus V2. And the work done in taking a charge from conductor 2 to conductor 1, you know that point charge. So there is a work done, and that means this is the potential difference. So work done in taking test charge from V2 to V1 from this conductor to this conductor. So this charge and potential are proportional. They are proportional to each other. And simply we can say that the ratio of charge and potential will be what? Constant. That means we can even say that Q by V is some constant, and that is C. And Q is equal to what? CB. This is the law of the capacitor, the principle of the capacitor. What is Q? Q is the charge. What is V? Potential difference between the two conductors. So this is what Q equal to what? CB. Now, if I ask you, capacitors, they are represented like this, like two plates. We have one with positive and another is negative. This is a fixed capacitor, fixed one. If I do like this, and there is an arrow, then this is variable capacitor. So Q is equal to CB, and what we can say is that C equal to Q by V. Now what is the SI unit of C? SI unit of C capacitor is, you know, that farad. So farad is written as F. Okay, so 1 farad will be 1 coulomb by 1 volt. This is the unit of farad. Okay, so this is 1 farad is equal to 1 coulomb by what? 1 volt. So capacitance is this, and capacitance of a capacitor can be defined as charge required to be supplied to either of the conductor to increase the potential difference by unit volt. And you know, generally we use 1 microfarad 10 to the power minus 6 farad, 1 nanofarad 10 to the power minus 9 farad, 1 picofarad 10 to the power minus 12 farad. And this is the capacitance. And you know, very interesting, C is ratio. So C is independent of Q and V. C depends on the physical factors because it is the ratio. So this is how we start with capacitor. You know that in Ohm's law it was V equal to IR, remember? And in capacitor it is equal to Q equal to CB. In Ohm's law, if you remember, what was R? It was what? V equal to IR, so R was V by I. Here C is Q by V. Ohm's law, you remember it? This was resistance. What was R? It was V by I. Now this is capacitor. What is C? This is Q by V. So these are the things which already we know Ohm's law. This is the law of capacitor. Q equal to CB. Now, if you want to go through the principle of capacitor, that also I can explain you. Principle of capacitor, very simple. Say there is a charged plate, you have taken a positive charged plate, you are supplying a positive charge on this. And there is a uncharged plate. Uncharged plate, then do you know what happens? If it is uncharged, this positive will induce a negative charge on this side. You remember negative charge, induction. And in the back side, what will come? What? A positive charge. In front, it will be negative charge. You remember, this negative charge is bounded, but this is free charge. This is a bounded charge, this is a free charge. And then what do you do? That this has a positive charge on its surface and this in front has a negative charge. What do? Do you know, you do the earthing. You supply the free charge down to the earth. Now this has what? A positive charge. Okay. And this has now what? Negative charge. This has plus Q, this has minus Q. And there is a potential difference between them. So we know that Q by V is always a constant, and that is C. So this is how we can, this is a charged plate and it was uncharged plate, then there was an induction. In the front it will be negative charge bounded, in the back it will be free charge. Then what you do, the free charge goes to the earthing. You have done earthing, then one has positive, other has negative. So this is how positive and negative. So this is Q equal to CB, principle of capacitor. Okay, now capacitor are of different types. So first of the most of the capacitors, you know, that cylindrical capacitor, spherical capacitor. Then there's a very important capacitor is parallel plate capacitor. Now what is a parallel plate capacitor? This is in your syllabus. This is the main content. You have two plates like this. Like I gave you the principle of the capacitor. We have like two plates here. So we have two plates like this. One plate has what? A positive charge here. And the other plate has a negative charge. Okay. These are this. And this has positive Q. So this will be what? Having negative Q. And there's a distance between the plates, if you see. So D is the distance between plates. Okay. Q is charge on plates. And do you remember sigma? Charge per unit area. That is surface charge density. It will be having plus sigma, it will be having minus sigma, you remember? Sigma. And what is A? It is area of the plates. This is area of the plates. And you remember the electric field lines. The electric field line, they will move from positive to what? Negative, you remember. And you know that by Gauss theorem, we have already calculated that electric field here, it will be sigma by epsilon naught between the plates. This we have done in Gauss theorem application. So this is a parallel plate capacitor. A parallel plate capacitor, it consists of what? Two large plane, we can say plane conducting plates. Plane conducting plates separated by a small distance. So this is a parallel plate capacitor. Now can you find out the capacitance of this parallel plate capacitor? Yes. Very simple. How? Say what is C is the capacitance. Say C is the capacitance here. C is the capacitance. We know that what is Q? It is CV. In place of Q, can we write sigma A? Yes. CV. What is potential difference? If you remember, potential difference is what? Electric field into distance. You know that V equal to ED. We can write V equal to ED. So V is what? ED. And then sigma A, C, what is E? E is sigma by epsilon naught. What? D. Then sigma cancels out, it goes here. So it will be epsilon naught A into CD. And finally, C is what? Do you know? Epsilon naught A by what? D. So this is actually the capacitance, which depends on physical factors. So again repeating, Q is equal to CB, principle of capacitance, Q is sigma A, potential difference is electric field into distance. You know that E equal to dB by dr, it is like that, sigma cancels out, C is epsilon naught A by D. C doesn't depend on what charge and potential, but it is what? Directly proportional to area and inversely proportional to what? Distance. More is the area, more will be the capacitance. More is the distance between the plates, less will be the capacitance. So this is epsilon naught A by D. This is the parallel plate capacitor. And if you remember, if you take any other medium, you remember, if you take any other medium, say this is the parallel plate capacitor plus Q minus Q. Now you got it, the distance between D, and this is epsilon naught A by D. Now if any other medium, you remember in Coulomb's law also any other medium was represented by epsilon, and epsilon is epsilon naught into epsilon R. So C medium will be what? Epsilon A by D. In place of epsilon, we'll write epsilon naught into epsilon R A by D. And how many of you remember epsilon R is capital K dielectric constant? Remember it? Dielectric constant. So can I write Cm equal to K epsilon naught A by D in place of epsilon naught K? So finally it is K times what of C. This is another very important. If it is filled by some medium of what? Epsilon. And we know that epsilon is what? Epsilon naught into epsilon. So K can also be defined as Cm by C. So this is dielectric constant. Already we have gone through it in Gauss law, Coulomb's law, electric field intensity, flux. Now today we are talking about K. K is the ratio of Cm. Cm is what? Capacitance in any medium to the capacitance in air medium. C was the capacitance in air medium. Remember, it was in air medium. And Cm is in capacitance in any medium. So this is another very important concept related with the capacitors. So got it? Now, I will just give you an example. Say there is a question that a capacitor has 20 microfarad in air medium. Okay? If the distance between plates is half and filled with dielectric medium. You know dielectric medium of K equal to 4. Then find the capacitance. See here, very interesting, find the capacitance. So very simple. What is the capacitance in air medium? It is 20 microfarad. And what is the air medium capacitance? Is epsilon naught A by D. In any medium, in dielectric medium, it will be what? Epsilon naught A in place of epsilon naught. It will be directly, you can write epsilon. Okay, epsilon A by what? And distance is D by what? 2 half. So it will be 2 epsilon A by D. And do you know epsilon in place of epsilon naught into epsilon R A by D? So can we write 2K epsilon naught A by D? What is epsilon R? Is K. So it will be 2K times of what? C. So 2K is what? 4 and it is what? 20. So it will be 160 microfarad. You see here, this was in air medium, this was in any medium. Then you half of the plate, you tried it, it is. So do you know Cm is greater than C here? So this is the capacitance, how the capacitance is increased in air medium. So finally, parallel plate capacitor, you have calculated, you know that if it is filled by with any medium, it will be Cm times of K times of C. K is this, and this is how we calculate the capacitance of any medium. Now, you know that the capacitor can be connected in series and parallel also. So, capacitance of capacitor, okay, one is series combination, and one is parallel combination. Got it? So series combination, how we are going to add them all them? So 1 by C equal to 1 by C1 plus 1 by C2 plus 1 by C3. And in parallel, it is C1 plus C2 plus C3. And in series, they are connected like this. They are connected like this. They are connected with a battery, and this is plus minus plus minus plus minus. Okay, and this is C1, C2, C3, and this is potential difference V applied here. And in parallel, they are connected like this. They are connected like this. And there's a battery which is connected this. So C1, C2, C3, this is plus, minus, plus, minus, plus, minus. But this time in this charge are same, in this charge are different. So this is series and parallel. In next one we are going to prove about the series and parallel. Okay, and thank you. Regularly watch my videos.